BB LAS absolute Y indexing addressing mode. So this opcode is essentially part of it's a load execute opcode, which means that it will only use 4 clock cycles if there's no page boundary crossing during the effective address. So this opcode supposedly loads registers A, X, and also the stack pointer with the effective address calculated here and it's fetched here. So this value gets ANDed with this value and it gets updated here, A, X, and S. Now, one thing I'll mention about the program is because we use PLP here and PHP here, the stack pointer is getting incremented and decremented by our program, which is why you're going to see the results of A and X not matching S. S is effectively going to be one count smaller than these. So anyways, if we modify the immediate, what we can see is that the immediate has a direct effect on A, X, and the stack as well. And like I said, it's going to be one count lower. So we got one F here, one E, and so forth. So F8, F7. So that, like I said, that's just because of the push P happening after the opcode executes. Setting the immediate byte to 1, all ones, we try doing the same thing with the stack, and again we can see that it's affecting A, X, and stack, and in this case, because the stack is pushed and then popped, this is exactly the same as this, whereas these this is E0, these are E1. So that's basically the explanation of the of opcode BB. I'm not sure what it could be useful for, but yeah, none of these other registers really do anything. And yeah, it does seem to affect the sign and zero flags. I mean, that's pretty routine. Program counter doesn't really do anything, because guess what, it shouldn't affect reliability.